H is for holding potential. It's a potential that is fixed, that is constant. Therefore, this factor here, VH minus equilibrium potential of the ion, is a constant. And the only variable is the current carried by the ion, so I ion. It's a unitary current through a single channel of conductance gamma. So we can measure the unitary current like that. It's the same for the total current. We hold the potential at a fixed value so that the factor here, the driving force, is constant. We can measure the variable I, capital I, of the ion, which depends here of the conductance through the NPO open channel. G equals NPO gamma. Now, if we wanted to measure a change in potential, what are we going to do? We want to measure here Vm, the variable. E ion is a constant, but I ion is also a variable. So we say that we measure in current clamp, but be careful, this is not the reverse of voltage clamp. We do not clamp the current. The current through the membrane is not constant. What we can do sometimes is to inject a depolarizing or a hyperpolarizing current to change the potential of the membrane. But it does not mean that we clamp the current that is going through the membrane. Be careful. So what happens here is that we leave the potential free to evolve as it wants due to the change of currents through the membrane. So one channel or NPO open channels. How do we record electrical signals from neurons? We use electrodes that we also call pipettes. Here, they are shown in cross-section. These are glass pipettes filled with an ionic solution which conducts electricity, and inside the pipette is inserted a metal wire with which we record the signal. A neuron is represented here as a round cell. When we want to record the activity of a single channel, we choose the cell-attached or the outside-out configuration. In the cell-attached configuration, we attach the pipette to the neuron. If we leave it like this, we will measure the current going through the very small piece of membrane under the pipette. There may be one or very few channels in this piece of membrane that we also call patch. The pipette is filled with an artificial extracellular solution, and inside the neuron remains its intracellular physiological medium. To record a single channel in a very small piece of membrane, we can also use the outside-out configuration. This means that the outer face of the membrane remains outside. How do we get it? We simply pull and excise a very small piece of the membrane and hope that there are channels in it. Notice that in this configuration, the pipette contains an artificial intracellular solution. When we want to record the activity of many channels, we choose the whole cell configuration. We start by attaching the pipette, this time filled with an artificial intracellular solution, to a neuronal soma. Then, the researcher creates a negative pressure either by sucking the air in the tube attached to the pipette, making this characteristic little noise, or he does it with a syringe. This removes the patch of membrane under the pipette. Then the solution inside the pipette gets into the neuron through the hole thus created. The pipette is now electrically connected to the entire neuronal membrane, and the researcher can record the activity of many channels. Overall, throughout the course, we will see these three configurations.